For this week's extra credit for the 6 weeks, week 2 or 3, I think it's 3, I'm going to be reviewing chapter 9 and 10. I've previously reviewed chapter 9, but I haven't reviewed chapter 10, so I thought I'd go back and refresh some of the chapter 9 stuff that I went over, and then go in and talk about some of the chapter 10 content, because our upcoming test on Tuesday will be over both. Okay, starting out, we're just gonna review this because it's good to use, and it's a big part of our test. The formula is a(n) equals 3 parentheses -2 to the n exponent. Essentially, we're going to be taking whatever number is paired for 1, because that's in correspondence to n, and we'll be inputting it back in for the n into this equation. So to start, we'll have 3 parentheses -2 to the first power. Make sure to use the parentheses, because if not, you can end up multiplying them wrong, having the exponent go somewhere wrong, and the problem can end up wrong. So we'll have -6 for a to the first. Then we'll have 3 parentheses -2 to the second power. That'll give us 12. 3 parentheses -2 to the third power. As you can see, it's flipping back and forth between negative and positive. And that's because when you have a positive exponent, it'll cancel out this negative, and when you have an odd exponent, it'll keep it as negative. So even and odd, they'll switch back and forth. 3 parentheses -2 to the fourth power, 48, because 4 is even, and then 3 parentheses -2 to the fifth power. That'll be -96. So we'll have a to the first is -6, a to the second is 12, a to the third is -24, and a to the fourth is 48, and a to the fifth is -96. Moving on to this, we are given we're trying to find the first term, and we know that the second term, which, because we know it's the second because it's a to the 2, is 6, and we know that the fifth term, because a to the fifth, is 6/25. 6 divided by 125, just having a decimal, is 0.048. So, because my calculator won't put it into fractions, so the answer is right here, but we're gonna have to solve it first. So I'm trying to think of something that goes into 125 and 6. Like, they could be multiplied, it could be divided, it could be added. We know that it's going to be divided, because since this is 2 and this is 5 and it kept getting smaller, we're going to have to divide by something. So I'm going to start out with a number that I'm just going to assume because of 125. I'm going to go with 5. So we'll have 6 divided by 5 is 0.12. That's to the third. Divided by 5 is 0.24. That's to the fourth. And then divided by 5 is 0.048, which we know is to the fifth. So then we need to go back to number 2, which is 6, and multiply by 5, because we're going the other direction. We were going backwards at first, now we're going to go forwards. So 6 times 5 is going to give you 30. So a to the first is going to be 30. Then right here, we're going to have an arithmetic sequence. And the formula for this is a(n) equals a to the first plus parentheses n minus 1 parentheses d. You need to make sure to keep the parentheses because they're in the formula for a reason. So we're provided with the information a1 equals 17 and d equals 3. So basically, we're just going to input a1 and d into the formula, simplify, and solve it. So we'll have, looking right here, we have 17 for a1 plus parentheses n minus 1 parentheses 3. And we can't leave it like this because it can be simplified more. So we need to do distribution and distribute 3 to n and 3 to -1. So 3 times n is going to give you 3n, and 3 times -1 is going to give you -3. But we're not yet done yet, because 17 and 3 are common, and they don't have an n, so we can simplify those. So 17 minus 3, and that'll give us 14. And we can have 14 plus 3n, or we can have 3n plus 14. It doesn't matter, just based on whatever you feel like within the sequence. Then we're going to do one more of these, and we have a1 equals 10 and d equals 4. So we're going to input a1 into 10 for right here, because this is our formula. An equals a1 plus parentheses n minus 1 parentheses d. So we have 10 for a1, and we have 4 for d. So then we need to distribute out, and it's going to go 4 distributed to the n is 4n. 4 distributed to the negative 1 is negative 4. We're going to combine like terms. So 10 minus 4 is going to give us 6. And then we'll have 6 plus 4n. And that's how we'll solve for the arithmetic sequence of this equation and this equation. Now we're going to solve for a geometric sequence. And the difference between geometric and arithmetic is geometric is multiplication and division, and arithmetic is addition and subtraction. And you need to remember those because if you use the wrong sign, you will end up getting the answer wrong. So you need to know the difference between geometric and arithmetic. So for this one, it starts out giving us 8, negative 4, 2, negative 1. And it wants us to establish if there's a pattern to them, and if so, what is the pattern. So as you can see, normally like these numbers like look divisible by each other, like they make sense, but we have to realize that there's a negative in between them, which is going to make a difference. Normally when you do, you have to take this number divided by this number. Negative 4 divided by negative 8. It's going to give you 0.5, which makes sense, but normally you would think that you would just divide the other way, or like divide by 2 and then divide by 2, but since this is a negative number, it's going to switch back and forth. So we'll do negative 4 divided by 8, which is going to give us negative 0.5. So that works for this one, because if you do 8 times negative 0.5, give you negative 4, but we need to check for these. So if you do 2 divided by negative 4, it'll give you negative 0.5, so that is the same, and then you can do negative 4 times negative 0.5, giving us a positive 2. And you can see that they'll flip back and forth because a negative times a negative will give you a positive, and negative times positive will give you a negative. You just have to remember to keep the signs the same. So when you go from this way to this way for this geometric, you're going to be multiplying. But when you go backwards, when you go from A2 to A1, you're going to be dividing. So yes, we know that the sequence is geometric, and it'll be done by negative 1/2 or negative 0.5. You just need to make sure that you look at these negative signs, because if not, you'll end up getting the answer wrong, because the negatives have a big importance and establish it to be a fraction rather than a whole number. Next, we're going to be doing a problem like this, which is pk equals k over 5 times 3k plus 8. Sorry, my 8 looks weird. Essentially for these, we're going to be inputting k plus 1 into every blank that's k, because this is the original problem and it wants us to put this k in for where this k is. So we have 2 k's in this equation. So first we're going to put k plus 1 in for that k over 5 times 3. You need to put parentheses because this k isn't being added to this 8. So when you put the parentheses, that'll separate the two of them out. So if brackets 3 parentheses k plus 1 parentheses plus 8. We're not done yet though, because we're going to need to simplify. So when you distribute out, you can distribute 3 times k, which is 3k, and 3 times 1. So 3 times 1 is 3, and then you can do 8 plus 3, giving you 11. So then you have 3k plus 11 times k plus 1 divided by 5. And that's the simplified version down of this equation. Then for this one, we're going to be taking parentheses, the foci of negative 5 divided by 2 comma 0, and putting it into this equation, which is y squared equals 4px. So we know that the foci and the p, we're going to be inputting whatever this number is into the p. So we'll have 4 parentheses negative 5 divided by 2 parentheses x. So when we do that, we're going to have to multiply these out. So you do 4 over 1 times the negative 5 over 2. And we don't have to change the denominator because this is multiplication and not addition or subtraction. So 4 times negative 5 is negative 20. 2 times 1 is 2. When you divide those down, you're going to get negative 10. And you need to make sure to keep the negative because there was no other negative in the problem, meaning that nothing could cancel out. So then we're going to have y squared equals negative 10x. And you need to remember to keep the x because nothing canceled out this x right here.